Hey guys, let's take a look at number 51, n queens. I think this problem is something we learned when we were at our college. So we are going to put n queens into this n two-dimensional matrix. So neither two queens at the same row or same column or at the same diagonal. Yeah, we need to return all possible solutions. Yeah, with Q stands for queen and dot stands for empty. Well, this is a typical backtracking problem. I think actually we have done a similar questions about the Sudoku. Yeah, if you haven't done that yet, please take a look at the videos of Sudoku in my channel. There is a detailed explanation of how it works. So yeah, so this problem is backtracking. For there are several characteristics. Like the first one, we need to find all the solutions. Yeah, there are some conditions that the solutions are not valid, are invalid, and the solution is complicated. Like it's a two-dimensional array. It's not a simple sum number. It's a number. It's not a number or a simple one-dimensional array. So we need to keep the board like global. And once we come to the last queen, and we will collect the result. And if it is, yeah, that's the basic idea. So the first thing we create the board, which should be array n field with 0, and we map it. Map. Because the dot stands for empty, so we fit it with dot. The other thing is that we need to create a for array to stand for the occupation of row or column or the diagonal. Yeah. Why we do this? Let's just first let's const cos used. Let's first, we just say we just initialize the variable, but we create the variable. We declare it, but we're not without initializing it yet. Okay. So the columns used, and because there are n queens to be put on this n chessboard, so each row there must be one queen. So there's no need to create a row used. We will do it like first put the first queen in the first row, but which we have n positions. That's what we're going to be concerned of. So yeah, and another one is whether this diagonal is used. So that will be diagonal. There are two diagonal, yeah, diagonal this direction and this direction. So this diagonal 135 degree and diagonal 45 degree used. Okay, not used. Yeah, used. Okay. So the recursion should be, we will put one queen to what column, right? It means to put a queen on the cell. That means const put ij, which means put the ith queen on the jth column. The row will be the same as with I, so the first queen will be put 0j from 0 to n minus 1, right? So when we try to put this queen at the position of ij, exactly, yeah, put it. We need to check if it is possible to put there, right? If not available, what does it mean by not available? It means the columns is used. The row is not used at all because we are putting the queen from top to down. So if column used j, or if the diagonal is used, if that's not possible, we just return. Yeah, if it is possible, if possible, we put queen in, which means board I j equals q. But we're doing it in the backtracking way. After we put this queen in the board, we need to put the next queen, right? So for the next row, there will also be n possibilities. So let's for I, not I, but k. We will put the I plus 1 next queen to k. Yeah. When we put the queen in, we need to update the flags, right? So this is true. This is true. This is true. When everything is done, when these checks are all done, it means the possibilities for me putting the queen on this position, all the possibilities are checked. So we need to revert the board. This is why we use a global board. If it is simple, we just put the result together into the iteration method. Yeah, here like result. Yeah, but now it's global one, so we need to revert it. So it's false, false, false. And there is another case that when we will collect the result, we will collect the result when after the last queen is put on the board. So if I equals n minus 1, this means last queen is put. Then we will collect the result. Okay, collects the result. The result should be empty array. Push the board, map, each row. Yeah, this is a result. Yeah, it says will be expression in a string. And if not, we will put next chess, put the next queen. And finally, okay, wait a minute, something wrong here. Oh yeah, it's right. Okay, okay. About the something wrong about the indentation, but anyway, so wait a minute, row here, else, it's right. Next thing we need to do is just to put the first queen, right? Yeah, the possibility is we put first queen, so 0. First queen to here, 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 or here. And finally, return the result. But these flags array are not initialized yet. We need to initialize it. Array n, there are only n columns, so field false. About diagonal, there will be 1, 2, 3, 4, 8, right? N, this is n. This will be n minus 1. So array n minus 1 field false. Yeah, diagonal 45 is the same. Here is the problem. This is J is for the row, but the index for diagonal is not, right? So we need to say index of diagonal 140, 135. What is it? 145 is this, so we count the index from right to left, okay? So what it should be? It should be the depths from top right. If it's 0, 0, it will be the n minus 1. If it is 1, 0, it will be n minus 1 plus 1, right? So it should be n minus okay, wait, it's I plus n minus j minus 1. Okay, so update the index of diagonal 135. Also, the index of the diagonal 45 mean this direction. We start from left, so it would be simply as I plus j, right? 0, 0 is 0, 1, 2. It actually is the depths from 0, 0. Yep. Let's check it one more time. If it is 8, 1, it should be 1 for diagonal 1 for 135. 7, 1. 7, 1, 8. Wait, 7, 1. So it should be 7, 1. 1, 1, 0, 8, 1. So it should be 1. So yeah, this is right. Okay, let's run the code. In the meantime, we calculated. We got some duplicate results. I think there's some problem here. After we put the nth queen, we'll push the result. For put the first one. Oh god, I forgot to diagonal update the index here. Okay, 45, 45. Run the code. Cool, it's accepted. Submit. Yay! We are accepted. So let's take a look again at this problem for the time complexity. Well, the time complexity, it's for every Every time we put a queen on the board, it will cut down at least n possibilities, right? And averagely, I think averagely it's something like if we put I don't know how to calculate the time complexity. The first one, which will be n possibility for the first queen, and then it will be okay, let's just do some calculation. The first chess will be 8 possibility, not 8 but n. The next one, if MP is here, so it will be 6 possibility, right? At most 6. The worst case is 5 for 8, so it should be n minus 2 plus the next one. It will be also, if it's at maximum n minus 2 minus 2. So n minus 4 and minus 6 until there's only one possibility, right? Until there is only one possibility, so there is only one. It's kind of like n square. Yeah, I think so. So the space, I'm not sure whether I get it right. I think we can add test the log, just count, add some console log here, and count how many times this put function is called. Yeah, let's try it. So let's say count equals 0, and here will be count plus equals 1, and here we console log count. Let's say something big like 20. Let's run the code. Space. Wow, there must be some certain mathematical correlations. Oh wow, it's time. Time exceeded. There's no maximum for nth. Let's say it's 10. Space. You see, we check it like 34. Wow, so it's not like this. Oh god, it's my bad. It's not like I made a mistake. It's not like this. This should be times. Yeah. That's why we checked for 348,000 times when n is equal to 10. Well, it's some number, but I don't know what it is. And space, yeah, there must be some result, but I don't know what it is. Anyway, that's all for this problem. See you next time. Bye bye.